All right, as I said, welcome. This is going to be over some machine parameters, NC parameters, and the NC editor. We've been getting a lot of good feedback from people about these webinars because they cover things that some people don't quite understand all of the settings and parameters, and it's good to know where those are because there are some useful ones in there. Probably will be one of the shorter sessions that we've had in this series, but I think it's an important one to cover these. So we're going to start with the machine parameters. We go to the auxiliary menu, then go to utilities and user preferences. We have the machine parameters soft key down here. We'll go ahead and select that. And that's going to bring up a set of parameters that have different pages you can go to if you look down the right side here. We go to the different menus. So this first one, the General 1 tab, the very first one is the control power off time. If you've ever stepped away from your machine for a period of time and then came back and noticed that it had gone into basically an e-stop condition, this is where we set the timer for how long the machine will stay powered up without any activity. In this default setting, I believe is 120 minutes. After that, the machine will just go ahead and shut itself down into an e-stop condition. It doesn't turn the control off or anything. It helps save power, and so you're not continually pumping way lube to the axes. The next one is the UPS, or Universal Power Supply. This is a backup system that can be purchased and added to the control. So if there's a power loss, it will go ahead and systematically shut down the control the way it should be, so it doesn't just kill power. And this parameter sets how long it will wait before it goes ahead and shuts down the control. The default is 1 minute. These are minute radians here. Also, along with that, to retract Z upon a power loss, once the control has determined that it did have power cut off to it, if it has the UPS, it'll go ahead and lift that Z axis up a bit so it doesn't gouge the part. Auto balance enable is really nothing that you'll mess with as a user. This is probably more for service. It has to do with balancing of the drives, and that's an electronic term. So probably nothing you'll ever do there. The next one here is the increment parts count at the end of a program. If this is set to yes, and you're using your parts counter, every time it sees that end of program or an M30 in the G code, it will go ahead and increment your parts count by 1. If you want that to be disabled, you can just go here and put this to no, and then it will not do that. This one is one that is a good one to know. Disable the auto on chip removal. What this means is as soon as I go to auto cycle start, if this is set to yes, then or set to no, then the chip conveyor will automatically start running. And if you don't have a barrel or a chip pan underneath it, then you end up dumping chips out on the floor. So turning this one to yes or no if you don't have a barrel under there, you're going to want to set this to yes. You want to disable that auto chip removal on, so you won't end up just dumping things out on the floor. And that way you can still turn it on using the buttons on the soft keys to turn it on and off while you're running, but this will just keep it from automatically coming on. Along with that, we have the chip removal on and off delay. So you can turn this on, and then you can have the chip removal. It will go for a period of time and then stop for a period of time, then go for a period of time and stop for a period of time. That gives it time to fill up the area of the conveyor that is in the machine, then it'll move for a few seconds and then fill it up again. That way you're not just continually running and coolant is going out with the chips and you end up with a barrel full of coolant that is stuck to that, or you end up with running the machine low on coolant very quickly. So you set this to yes, then you can set your time for on and off here, and as it says, they are in seconds. So that's everything on the General 1 tab. Let's go to General 2. Disable the tool picker station. This defaults to yes, I believe, because the tool picker, if you have a larger machine like a VMX 64, you may have noticed that on the left side of the table there's a little hole. You can buy a cradle that will hold Big Cat 50 tools that you can set in that cradle, and it's a software option that when you do a tool change or you want to put that tool in the spindle manually, it will come over and get that from the cradle. So this is where we determine whether that tool picker station is disabled or enabled. So that's what this one is. And if for some reason you were having some service issues with your tool changer, your automatic tool changer, if you needed to disable that so you could continue on running your job using manual tools, then you could disable that here. Probably not something that you'll ever do, but your service tech may at some point. All right, so move to a safe position manual mode ATC. In the program parameters that we covered previously, there is a setting for go to safe position during tool changes, and that is only during automatic operation. So when you're in the program parameters, that's only for auto. During manual tool changes, it still will ignore that program parameter and do whatever is set here. So if you have a VM10, for example, you have a pretty tall part in a vise in the middle of your table, then you may want to send it home before you do a tool change, just so you don't have a collision between the tool being pulled out of the spindle and hitting the top of a tall part. So anyway, that's where this is done. And again, once this is set, it's good until you change it. So it doesn't matter which program is active. You do an a manual tool change, and that will take over. Here is the tilt axis safety position in degrees. So if you had a 5th axis machine, or I guess even a 4th axis rotary, if you needed it to go to 90 degrees or something during a tool change, then you would put that here. Here's an X and Y position that if I flag this to yes, then it will go to this position here, and it is a machine relative coordinate, not a part relative. So you would need to find out what that machine relative position is, type it in here, set that move to safe position manual ATC to yes, and then you will go here during all your tool changes. Also, along with the 4th and 5th axis machines, if you are going to reorient switching between tool transform planes or something like that, and you can enable these two and then give an X and a Y position. Also machine relative to tilt that axis to while you're doing the reorientation. If the control during a check for errors, or if you go to run the part or something like that, and you're going to be out of position in one of your rotary axis, then this flag is going to determine how do you want that to be taken care of. Do you want to get a warning? Do you want to get an error that'll stop the machine, just a warning that pops up, or ignore it? If you ignore it and it is physically cannot get there, no matter what tilt axis preference you have, it will still go ahead and stop. So ignore and error are pretty much going to do the same thing. So that's everything on the General 2 tab. If we look at the coolant, we have the flood and secondary coolant. Secondary being through the spindle coolant. When you first initiate a tool change, you position to your Z start in a conversational program, for example, that's when the coolant kicks on. Well, depending on how long it's been since you ran your coolant, if you've moved the Z up and down several times, maybe you're a little bit low on coolant, sometimes it won't immediately come on. What this is a pause in seconds that you can put, that once that tool or that coolant has been energized, the control will wait this number of seconds for either the flood coolant or the secondary coolant before it continues. That'll give it time to go ahead and charge the system, and you will have coolant at the tip of your tool. If you have a Max 5 control, that's one of the new controls, you have a auxiliary button on your coolant. You've got auto, primary, secondary, and auxiliary. This using a number 1 through 12, and it kind of depends on who set up your machine usually, but you can play with those numbers and get that auxiliary button to, on a VMX, do an air blast, for example. It'll force the air on. You could use it for your secondary coolant if you've got primary or whatever. If you need to use that auxiliary button, you can play with this numbers 1 to 12 and get that to do what it is that you need it to do. The pulsating or delay wash enable. So we've got a couple of options here that you can set. So when you turn on your wash down on your control, you either have it on or you have it off. We can also set it to pulsate, meaning go turning on for a period of time, then turning off for a period of time. Turning on and turning off. That way we can keep chip dams from occurring on the wave covers. We can also have it where it goes back and forth between the two. It'll alternate between the left side and the right side. So this is where we turn that on and have the different timers here that we can use to set those things. So that could be useful, especially if you're on a larger VMX machine. And this is only available on VMXs, obviously. This next one is overrides. On the new Max 5 control, you may have noticed that there is the feed override, the rapid, and the spindle. They all have kind of you can push them in, if you will. Well, that's what some of these settings are for. We have the override minimum. If you set this to 0, when I turn the override all the way down to 0, the machine will stop. If you have an older Hurco, you know that it used to be in Ultimax, it would 10% was the slowest you could go. Well, now we can stop it. We have been able to do that for quite some time now, but 0 is your minimum. Then you have a nominal and a maximum. These are ones that you can't change, but obviously your nominal is going to be 100%, and then you can go up to 150% on feed and rapid. I'm sorry, on feed and spindle, I believe. So that's where we can set their minimum here. The override increment. This is going to determine how sensitive your override knobs are. And you'll notice that we have one for feed, rapid, spindle, and jog. We have different settings for all of those, each individual knob. But this increment is going to determine how touchy that is. So if we have it at fine, then you can turn it quite a bit before you really start to see it go up. It's a little more controllable. If I go to coarse, it's a little harder for me to fine adjust that RPM, but you can adjust that here to whatever your needs are. Now, I told you that the buttons on the Max 5 control, that's the new control panel, they push in, and they come disabled as a standard setting, but we do have for a quick press, meaning you literally just press it for a brief second, or you can press and hold it, and then I can set what I want it to do. I want it to go to minimum, I want it to go to nominal, I want to go to user defined, then I can put something there. So disabled is what they come default to, but you can change that. And again, we can go for the rapid, that was the feed rate, the rapid, spindle, and then the jog knob that is on the actual pinion itself. So these are pretty useful. We see a lot of people go in here and kind of fine tune things to fit their needs. The calibration and warm up, probably no need to change anything in here, but this is where the control gets all of its information for the warm up cycle. What are the feed rates that it's going to move? What's RPM does it start with? What does it end with? And things like that. So this is probably not one that you'll play with, but at least you know where those numbers are coming from. Auxiliary outputs. This will be something that service guys will probably mess with, or your maintenance people if you wanted to add an auxiliary output, meaning maybe you've got through the spindle, an air blast on your machine that is fired with an M52. They would use this screen here to help set up those outputs that are controlled with M codes for on and off. So again, maybe or may not be something that you'll ever get into, but when you see it, you'll know what those are for. And the last one on this section is the estimated runtime. If you're doing an estimated runtime and you realize that you're constantly coming up with too much time, or it's telling you that it's going to take 3 minutes when it actually takes 4 minutes or something like that, then you can come in here and add time or decrease time if you need to kind of help bring that a little bit more in line, especially if you're using this for quoting, or if you're using your compute estimated runtime to quote jobs, or if you're trying to use that for planning, then this will give you a really good idea of what your actual time is going to be. And you can add these values here for things like the clamping of axes, conveyors, kicking on and off, whatever. So you can put some time in here to help dial that in to get a number that you can trust. All right, so that was the machine parameters. Now I'm going to go to the NC parameters, and those are under the program parameters section of the control. They're available even when you have a conversational program up, but these only really affect the NC programs. So the first one is the NC configuration parameters. Now we're going to cover all of these, but the reference point ones are the ones that we see people use a lot, especially after they find out that this is available. So anytime that you are leaving a decimal point off of something, then here it's going to determine what the unit is. If I just do a 1 enter, it's going to assume 0.001. I can set that then to change those if I want to. Scaling factor works the same way. If I don't want to be able to use a G50, G51 to scale the program, or if I never want to be able to scale it in the Z-axis, for example, I want my depths always the same, then I can go in here and I can disable the scaling for that particular axis. Again, Z is really the only one that I could think of that would be too beneficial, but this is where we can turn that on and off. Now the reference point, X, Y, and Z, this is with the end of your program. If you call it G91, G28, X0, Y0, or Z0, it's going to go to whatever machine position. This is a machine relative coordinate. It's going to go here. So what we see a lot of people do is leave X and Y alone, or leave Z alone for sure, and they might put X in the center of their X-axis travel. Like on a VMX 42, this would be a 21, and there's 24 inches of travel on a VMX 42, so they might put 24 here. That way, if they do a G91, G28, X0, Y0, it'll send the table out to the operator at the end of the program. So these are pretty useful ones, and this one we see a lot of people change. Pretty happy when this came along because it gave everybody the ability to get that table position. Tool length tolerance is a new one. I actually was talking to some of the people in engineering today trying to find out what that one was because I had never seen it before, and I still don't have an answer for that. So your control may or may not have this. Again, it's fairly new. Today was the first day that I'd seen that, so I can't tell you what this one's for. The General 2 tab, a few other things here. The M6 is going to initiate a tool change, default tool number, 0, I guess, if for whatever reason you reset the control, or it won't automatically assume there's one in the spindle. Really don't know why that one would be there, or what an example would be for that particular parameter. Allow vacant variables. This is a good one to leave at yes, especially if you do anything with either probing or any other kind of macros. We want to allow for vacant variables. Assume the feed rate. Again, if I don't put in a decimal place, how is it going to handle that? The default cutter comp look ahead used to be a number we could change in older controls from 1 to 8, and typically 1 worked the best, so they finally locked it in at 1, and we can't change that any longer. But if your control does have a number here, it basically helps it look at the number of intersections in a series of moves, and it uses those intersections, or how many intersections ahead it looks for cutter comp movement. So you may get some odd behavior. It may, for example, if you start and end in the exact same point on a circle that's broke into 2 arcs, and you have this set to 2, well, it's going to look 2 intersections ahead, say, well, I'm already in that spot, and then it would just ignore the circle. So if you're ever running a G code where things are being ignored, it's not doing circles, it's not doing arcs, it's not doing something like that, then you may look, this parameter probably is open on yours, and you would want to change that down to a 1. 8 used to be the default, I think, or 3 did. Lead in and lead out checking, whether you want that on or off. If it's on, you'll get an error. If it's off, it'll just ignore it. And the same with cutter comp reversal checking. These are the default settings. There are some specific times you might change those, and for the most part, these are all set the way they should be. Intelligent ASR, that's automatic safe reposition. This has to do with a 5-axis machine. Every time on a 5-axis that we change transform planes, every time we have a new plane created, we are going to automatically retract along the tool to the limits, move up Z all the way home, and then orient. Well, if you don't want to do that, we can turn on the automatic safe repositioning. There's a safety clearance, there's a vector retract, and a Z limit override. There's some settings I can do here to create boundaries, if you will. So the safety clearance, the vector override, this is how far away, the retract override, how far away from the part do we move along the tool axis. Safety Z is basically your safety clearance above the part for the point you're going to move to. And then you have the Z override limit, which means the actual head of the machine. You're trying to limit it to a machine relative position here. The control will use the safety clearance and the Z limit. It'll pick the safest of the two. But this does give you a little bit of control over whether or not the control is going to go all the way home between a plane change. A lot of people aren't aware that this exists, but they do complain that I've already run this 4 times. I know where I should pull to. I'm not going to wreck anything, but this is taking too much time. You can help reduce that a little bit here. And if you look in the help menu, there are some pretty clear instructions over this area. And then this is for all transform planes, conversational or NC, but then you have some things in the G-code programs alone, like M128s, or if you're doing an M6 tool change, that will trigger different things. So again, you can look at that in the help section, or feel free to send something to applications@hurco.com for specific questions. If you've got a specific need for this, they can help walk you through it. All right, the NCMG code parameters. This will give you the ability to have a user-defined M or G code. If there's something specific you need, I don't know if it's a palette change or whatever, that you need to be able to call your own specific M or G code, then you can go to this section. You can enable M codes for either NC or conversational. G codes, obviously, for G code only or NC only. But that opens these up. So then I can go here, for example, let's say I wanted an M200 to do something very specific. Every time the program sees M200, it's going to run program 9001. And you would have to create that macro program or that program of 9001. It must be open in the program manager, but this would basically, M200 would then go out and execute that program. So if you have some specific things that you need to do and you want to control that with an M code, then you can do that right here. Not a lot of call for that, but again, for ancillary things like palette changers and so forth, we have seen people do that. So that's where that would be done. NC variables. In the event you are going to write an NC program or a macro program, you need to set some variables. This is where they are. You see that you got some global parameters here, tool length offsets, work offsets, and so forth. But if you want to know what a specific one does, if you go to the help menu, you click on this top index or this top tab here to contents. We're going to go to NC Programming, NC Productivity, and NCPP, which is NC Productivity Package, Variable Summary. In that, we'll explain what each one of the variables are. For example, here your work offsets, 2501 to 2506, it's the X or G54 through 59, and things like that. So this is where we can go to find out what this, what each one of these actually does. But again, variables are under the NC Variables tab. I'm not a macro programmer, so can't really give you any direction on how to do that. But if it's somebody who's needing that, I'm going to assume that you are. All right, well, that pretty much covered those two sections, the machine parameters and the NC parameters. Now we'll go into the NC editor. The NC editor, you really don't need to know anything different than what we had before, and there's a lot of the same things in here for search functions and so forth, but there are a lot of other settings in here as well that make it pretty nice to help the operator make the program appear and so forth the way that they want it to. So let's just go down the list here. The edit functions, I can cut, copy, and paste just like always. I can, highlight a section of the program, then I could cut that, copy it, move cursor, paste it, redo or undo, things like that. We are going to always be in the insert mode, meaning if I were to put the cursor before this M3 and start typing, it's going to insert whatever I'm typing right before the M3. I can also do an overwrite where if I start typing, it's going to just replace whatever is there. So that's what we do here. You also notice down here, I am on block or line 1 in the 10 in the program, and you see that that's what we're telling it down here. I'm on line 10. I'm in insert, not overwrite. If I change that here, you'll see that switch to overwrite. Block skip is on, block skip enable is on, and we're in an industry standard NC program. I can also highlight this M140, for example, and it tells me that that is a retract along the tool vector. If I go to M59, that turns the chip conveyor on in forward mode. G20, that's an input in inch. So if you see a code, M code or G code that you don't recognize, or for that matter, even a Y-axis move, it'll tell you what that is that you're highlighting. The jump and search functions, we can jump to the beginning of the program, jump to the end of the program. I can jump to a specific block number, which is a line number. For example, if I highlight here, I am now on line 17. I could jump to a sequence number, which are the little N numbers here. So I could just go to jump to sequence 20. It will take me to line 20. I can find text, anything that I'm specifically looking for. I can find and replace, so I can find all feed rates of 21.1 inches and change them all to 20 inches or something like that. So that is in the jump and search functions. The tagged blocks, that's a pretty good way to, let's say I'm going to go down here to this N151, and I'm going to tag that block. Now when I'm somewhere else in the program, I can jump to the next tag block, it'll take me to that. And if I had more of them, I could just keep hitting jump to next tag block and it would take me to the next one. Or I can hit a tagged block list. Let's tag a couple more here. I can look at this list and it tells me each one of those spots where I have a tag. It does not affect the way the program runs in any way. This just helps me navigate the program if there's somewhere I'm going to often, and I can just double click on that, it'll take me back to it. I can also, see, tag blocks, tag, and clear all those tags. So If you're editing a program or you're constantly doing some rework maybe and you're going to one specific spot in the program to keep that going, then that's one way you can do it. We also have start and end markers. So if I were to place a start marker here, you're going to see a little S, an end marker, there's an E, and when I hit cycle start, this program will start from the S marker, run to the end, the E, and then stop. And it will stay that way until I reset those. So again, I'm doing some rework. I only have to run the last section of this program. I made some adjustment, and I'm just running tool 1 to whatever. I don't have to edit the program. I can just put a start marker and an end marker. We can put in a graphics marker. So if I've got a large program and I've already proven out some of it, I don't have to watch it all run. I can just set a graphics marker, start, end, and everything between there will get graphed. Nothing else will. And then jump to those different things. So there are your start and end markers. And the last little section in this is the editor settings. So you'll notice right now, I'm going to jump to the beginning here, that everything in parentheses is in green. All of my in or sequence numbers are kind of a pink color. Other stuff is in blue. Syntax stuff will be in red. But under the editor settings, I can set what all that is. So here's my unmatched or my syntax errors in red. The sequence numbers are in pink. I can just go over here and change that, make them more of a dark red. I go back to the program then, those are now red. But the really cool thing is I can go here to edit font. I can pick whatever kind of font I want. I'm just going to do Century 16, apply that, and when I go back, now I have a different font in a larger size. So it makes it a lot easier for me to see that, especially as we get older. I don't even remember what that was now. Anyway, so I can pick any of the fonts that I want and change the size, change the colors, set this up for me to make a little bit more sense. All right, so that pretty much covered the few things that I wanted to go through today. There's a few useful ones in there, especially that reference point return there for the G28. That's a good one. I don't see any questions popped up. At this point, I'll give it a few more seconds to see if anybody wants to type something in there. But if not, if you do have any questions on anything specific or you want a little more direction on something, again, applications@hurco.com, and we will try to get you taken care of. All right. Well, there's nothing popping up in the chat, so I'm going to go ahead and end for today. This was recorded. There will be a recording that is being sent to everybody that participated, and as always on the website under the support tab, you can go to these webinars. You can see all of them. This is number 12, I believe, to watch any ones that you might have missed in the past. So have a good day, everybody. Thanks for attending, and we'll see you on the next one.